Suresh Babu from Space Physics Laboratory of Vikram Sarabhai Space Center. So today, like you, I am also very curious to know about Moon. So I will be discussing with you or sharing some of the information which we discuss here on the Earth's only moon. So my area of expertise is atmospheric physics. I work more on Earth atmosphere, basically particles in the Earth atmosphere. You know Earth atmosphere, you have studied in your classrooms. But Moon always fascinates us. From our childhood days onwards, we look at Moon. While eating food also, first they show us, or mother show us, look at the Moon. And then so it's always part of our life. But it's, from the beginning, the scientific curiosity, scientific understanding on the Moon also, it's always from the beginning, our curiosity about Moon, because it is always visible with naked eye, like stars. So let us look at the solar system. First, we start with solar system. We have the sun at the center. It's a very simple picture. It's not necessarily like this, because it is never be coplanar. It is not, all the planets are never be in same planes, but planets roll around the sun. We say in an orbit, not circular, it is always in elliptic orbits. But if you look at, you can see the Moon near to the Earth. It's revolving around the Earth. So this is only to get a picture where we are. But as I mentioned in the beginning, Earth is having only one moon. But if you look at all other planets, you can see that multiple moons. So that's why for Earth, Moon is very important, for other planets also. But for our life, Moon is a significant role to play. That we will discuss how it is. But if you look at other planets, you look at Saturn, there are several moons. And if you look at the Titan, which the size is almost close to Earth, it's like a planet. And that is the case with many of the Jupiter's moons also. But if you look at the Earth's moon, there is one important point. If you look at the ratio of Earth's size to the moon size, our moon is quite big compared to our planet size. But compared to Jupiter size, these are all not that. The ratio is quite small. So our moon is quite big. If you compare to our planet size, Earth size, our moon size is quite big. But if you, while talking about Moon, we should look at the Moon, the only natural satellite orbiting the Earth, and is our closest neighbor in space. When it formed about 4.53 billion years ago. It's a very big number. Billion years is a quite big number, isn't it? Can you imagine 1 billion? So 4.53 billion years ago. The age of Sun, if you look at, it is around 4.603 billion years. And of Earth is around 4.543 billion years. And if you compare, when you look at the billion, these are all not so, it is formed more or less close time. One sun is formed, not so far Earth got formed and then Moon. Because if you look at the billion years, it is comparable. So how will you get this age of Sun? How can we get the age of Sun? Basically using the radioactive dating. You might have heard, you are in 8th standard told, but you will study in future more about radioactive dating, looking at the half-life of the radioactive materials. You can find the age even in billion years. So, but how will you get the samples, solar samples, to get this 4.603, this number? How can we get the samples? The samples are basically the meteorites or meteors. So we can collect samples in our polar region. If you go an Arctic or Antarctic region, it is all ice covered, where we can see this meteoric samples, rock samples can be collected, which can be taken to laboratories and did radio dating, and we can find the. So the longest one we can say is for the year, the period which we get from the meteoric rocks, we can consider that as the life, isn't it? But it depends on, because the one issue with collecting the meteoric rocks is our Earth has a thick atmosphere around us which protects our life. We are so cheerful sitting here because of the nice atmosphere we have. Though we are polluting our atmosphere through different activities, but our atmosphere is so nice that it maintains a comfortable temperature for us to live. Of course, it's part of evolution, we got adapted to that, but still the temperature, the comfortable temperature is because of the thick atmosphere we have. But this thick atmosphere will give frictional forces. When the meteors enters the atmosphere, because of the friction, this meteors gets burned off. And so getting meteoric rocks or in Earth atmosphere, in the Earth's surface, there are a lot of difficulties because it is not so frequent. In the past it has happened, but in the recent time, if you were to get such sample to do the analysis, whether it is formed Earth's rock or which is came from sun, we have to. So to get those things, one of the best place to look at is to get the samples from moon. So that's why this is, if I borrowed from a NASA website, the sun is telling, oh, you are the person who told them about my age. So the moon gave us the rocks to get this age of sun. So, but you know that the sun, we get energy through nuclear fusion, which is happening in the sun. So these fuels are hydrogen is getting converted to helium, and there is a cycle. So once all these fuels gets consumed, and then the sun is a star, it will go into change the phase to a red giant, and things like that will happen. So there is a definite life for the sun. So what is the left out life of, in this contest I am telling, of sun is around 5 billion years. So we don't have to worry about that. Otherwise we have to worry. So anyone is here who lives for another 5 billion years, they have to worry. But we don't have to worry about that. Now, I always because he is, for me, is like God, because for any one who lives with science, you know him? Yeah, Galileo. So if you take science, there is science after Galileo and science before Galileo. Science before Galileo was mostly by Aristotle's thinking and things like that. Science based on observations and facts started with Galileo. So Galileo, with his telescope, he started looking at moon, and then he observed. He is the first person who gave very authentic information about the moon. What he told, so Galileo discovered that the moon has mountains, pits, and other features, just like Earth. And so, though he thought moon has an atmosphere, he concluded there are very little water on the surface, as there was no clouds. He could not see any clouds through his telescope. How many of you have your own telescope? You can have a telescope. Yeah, you look at moon, what Galileo saw, you can see now. Yeah? So, but the interesting thing is that he not only found Earth's moon, he is the person who discovered all the 4 moons of Jupiter. So that's the greatness of Galileo. And Galileo discovered many other things which we are studying. Galileo lived from 1564 to 1642, and in 1642 Isaac Newton was born. So there is a continuity. So where Galileo stopped, there Newton started. That is a different story. Okay. Now, I just show one small video which is an experiment as a tribute to Galileo in Apollo 15, one of the astronauts did. You just, I will, probably you can click there. Yeah, what it is actually, what Galileo told, if in gravity, if there is no atmosphere, if you drop a hammer and a feather, both will fall and touch this ground at same time. A hammer and a feather. So in Apollo 15, you can see an astronaut who is carrying one hammer and a feather, Is it? I don't know whether it is very clear to you. So he is dropping both.
And I'll drop the two of them here, and hopefully they'll hit the ground at the same time.
Both touches the ground at same time. The reason for that is there is no air resistance in moon. There is very thin atmosphere. Moon has very thin atmosphere. So this Galileo predicted at that time, because before the gravity, Newtonian gravity and theory, Galileo predicted that the air resistance play a major role when you drop two items. So the importance of gravity, and gravity is the one which controls all the planetary system. So it's good to read a lot about gravity that you can do. Now, you look at this, the mean Earth-Moon distance is about 3,84,400 kilometers, which is something like 1.3 light seconds. Because light takes about 1.3 seconds to travel from Moon to Earth. So this distance vary because this Moon revolve around Earth in an elliptic orbit. So this can be as close as 3.6 lakhs to 4.06 lakhs. But the important thing is, this Moon's orbit around the Earth has experienced dramatic changes since its formation. What are these dramatic changes? Which for me also it was very, Moon was 12 times closer to the Earth when it was formed. So when it was formed, it was very close to Earth, but over the years, this Moon is going away and away because of the tidal effect. We'll talk about that. Currently, the Moon is receding at the rate of 3.8 centimeter per year. This is called lunar retreat. So we may think that after some time, this Moon will escape from our Earth, because every year 3.8 centimeter, it is receding from Earth. So our Moon is going away from us. But you just keep this and calculate the time required, which I am not telling you. You can do it as a homework and find out how much time it takes to travel about 1 lakh kilometers. It will be quite, so much of time. So you don't have to worry that Moon is not going to leave us. If you compare it to the 5 billion years time which is left out for us to have Sun, this also will run to very big, huge number. So you don't have to worry about that. But still, Moon is going, because this number, if you see, if you look at 3.8 centimeter, and this is 4 lakhs kilometers. So, but still, it's a fact that Moon is going away. So in the time scales of billions of years, this number will be quite significant, or millions of years. It is significant. Now, the Moon and the Earth. Moon has affected the Earth and the evolution of life on Earth. Another interesting thing is here, gravitationally stabilized the orbit of the Earth with respect to its wobble. It's because of Moon. If you, I don't know whether you will be able to appreciate this. Here we have shown the obliquity, which is, our Earth's spin axis is about 23.5 degree inclined to the orbital axis, and that angle is we call obliquity, isn't it? So, and when it rolls around the Earth, it has a small wobble. But if that wobble is small because of the presence of Moon around the Earth, because when Moon is revolving around the Earth, there is a tidal force. What is tidal force basically? Because when Moon attracts the Earth, or there is a mutual attraction between Earth and Moon, so there is a differential gravitational force. Gravitational force, all of you know. So there is a differential gravitational force which leads that the oceanic water gets recede and comes closer. If you go to the seashore, you can get the feel of the tidal effects. So there is a net force which acts against the rotation, which is called tidal forces, which is a resistive force. So because of that, this wobbling is controlled. If there was no Moon around us, this wobbling would have been large. That is why if you see the red line, that is the wobble. This is a simulation. We cannot have a situation without Moon and do this measurement. So, but to do it using numerical models, we can simulate this. Okay. So this is like two fronts coming out of school, it's okay. In that one is little naughty, that fellow will make the other fellow to warble. So it is something like our friend Moon, he is very strong, he won't allow Earth to warble quite large. So the tidal effects reduced the spin of Earth from very fast. It was actually, our Earth was rotating with very high speed. Because of this tidal force, it is the present 24 hours is reached because of this tidal adjustments. So see, otherwise our day would have been only 5 or 6 hours. It was quite difficult for us. So Moon helped us in that. Now, the lunar tides brought marine life from seas. You know that the tidal effects. If you go to Calcutta, you can see that there these ships used to come to the shore based on this tidal forces. When the tidal waters were coming closer, then the ships will come. There are places like that. Even the port activity depends on the tidal thing. And even the lives, marine lives getting migrated to the land, and then this also, which, so this is so many ways it is connected, our thing, and much more is coming. Now, just you compare Moon and Earth. So, Earth radius we all know, it's about 6,371 kilometer. You can imagine from here to Delhi is around 3,000 kilometer or so. So, it's almost double of that. So, Moon radius is only 1,737 kilometers. The mass 5.9 into 10 raised to 24 kilogram, but for Moon it is only 10 raised to 22. The density 5.51 and 3.34, just to get a feel. So, because of all these things, the surface gravity is here, it is 9.8, here it is only 1/6, 1.6. The most important thing is the surface escape velocity. What is escape velocity? Yeah, if it is more than the value, it will leave the Earth's surface. If it is more than, if you throw a stone more than 11.2 kilometer per second speed, it will go out of the Earth's gravity. So for that, for Moon, it is only 2.38. So this is very important, because that's one reason our Moon doesn't have the kind of atmosphere. One of the reason, not one of the reason. Then the atmospheric density here, we have about 10 raised to 19 particles, 10 with 19 zeros. But for Moon, it is only 10 raised to 5 particles during day, and during night, it is only around 1,000 particles. So you can see what is the kind of atmosphere. Global magnetic field, that's very important. Earth is having a north to south. We know that we have a global magnetic field. While entering the museum, some of our friends might have explained to you why Vikram Sarabhai Space Center is at Tumba, isn't it? And what they told about the magnetic field, north-south magnetic field, which is in the equatorial region. It is very important to study a process called equatorial electrojet. So, we have a global magnetic field, but Moon doesn't have a global magnetic field. It's very important, because this magnetic field is helping us. Otherwise, the sun is bombarding so much of particles, not only light, so much of particles called solar wind. And it comes and these are all high energy particles. These high energy particles can come and create havoc. So, this Moon doesn't have such a global magnetic field. So, the solar wind continuously impact on Moon surface. So, that also will, take away the atmosphere. So, there are two reasons. So, the temperature, if you look at the day side temperature is about 120, night side temperature is about 180 degrees Celsius. It's quite cool, 120 degree Celsius during day, but here I missed one minus sign. So, now look at the Moon surface. Moon surface was classified into two distinct features. If you look at Moon, those who have telescope, you can look at Moon and see these features. You can see that there are dark areas, which is very smooth dark areas, and there are very bright surfaces, and there are certain craters. So, if you look at these prominent dark regions on the Moon surface appeared smooth enough because it is like ocean. So, Galileo thought that this is ocean in Moon surface, but later, kind of ocean kind of situation. So, he called this as Maria, which means, or mare, means marine regions. It's like so these dark areas are called Maria regions. are volcanic plains basically. So when this volcanic activity, now moon is geologically inactive, it's not active at all. But millions of years ago, the moon was volcanically quite active. So this volcanic lava which comes out of this eruption created this kind of very smooth surface, and it got, for years, millions of years, it got settled and become very smooth surfaces, black surfaces we can see. So this covers about 17% of the total moon, but moon surface if you take. Now, if you look at the moon, we always see that same side. If you look at, always moon looks like this. So we may think that moon never spins, because if it spins, we should see the other side also. So this may lead to an impression that moon doesn't spin at all, but that is not true. It cannot. No, in the two-body problem which you are going to study in future, you will understand that in two-body problem situation, an object in planetary object cannot be without spinning. So what's the reason for that? The reason is actually called synchronous rotation. So the time taken by the moon to complete one orbit around the Earth, which is around 27.3 Earth days. One Earth day is 24 hours. So moon take about 27.3 Earth days to make one orbit around the Earth. And that time, which is same as the time taken to rotate around its own axis. So what it is happening here, when moon is rotating around Earth, it gradually spin, showing only one face to us. So moon never show its other face to us. They know that we are, isn't it? So moon always hides something. That's why but we are very, intelligent. We started looking at it in the other ways, which we are going to discuss now. So then there is a near side and there is a far side. So the side which is visible from Earth is known as the near side, this is the one which we saw some time before. The far side looks something like this. So naturally a question comes, why the near side has more this kind of dark regions, marine regions or mares, but the far side doesn't have. This is also has the influence of Earth is also there in that, because when this volcanic activities happens, because of this Earth's gravity, this is something to do with the internal structure of the moon, which we are going to discuss now, is actually the crust is very thin in this region, and most of the volcanic activity happens in the near side. So we know this part, we all know the phases of the moon. Moon have different phases. We know there is a new moon, there is a full moon phase and a new moon phase, which you all know very well. What is that? Basically, when moon is between the sun and Earth, the visible portion of moon will be dark for us. But when along this line, when moon is in the other side, the sun rays will hit the portions which is visible to the near side portion. So we have the full moon situation. But when moon is between the sun and Earth, we have the new moon. So this we all know. You might have already studied this, but the time between two subsequent new moons is around 29.5 days, which we call it a synodic period. And the sidereal rotation period is the time moon takes to orbit 360 degree around the Earth related to the fixed star, which is around 27.3 days, which we told now. Now, some more things about moon. You might have read in some of the literature about blood moon, means very red colored moon. So there may be stories about blood moon. But actually what is happening, moon is always same moon only. But it is the situation which is that during the total lunar eclipse time, Earth lines up between the moon and the sun. So this you are studying in a different way. So this hides the moon from the sunlight. So what is happening is, when this happens, the only light that can reach the moon surface is from the edges of the Earth's atmosphere. So what actually Earth's atmosphere do? We study that sky is blue. Why sky is blue? Or during sunset, sky is red in color. Why? We say that the air molecules from the Earth atmosphere scatter most of the blue light, and what left out is red. A similar kind of situation happens. All blue lights will be scattered by the Earth atmosphere, and what reaches the moon surface is only the red light, preferentially. So when we look at that, the reflected light from moon will be red in color. It just normally happens during the lunar eclipse time. So there is another moon called the blue moon. We call it as once in a blue moon. You also many times, I see once in a blue moon. What is this blue moon? Is it blue in color? Is blue moon is blue in color? Have you ever noticed the blue colored moon in your life? No, it is never there. So then why it is called like that? No, it is never. So the reason is actually it is only a naming. Blue moon is used for the second full moon in a calendar month. Because of this 27.3 days business, once in 2.5 years, in 1 month we have two full moon. So the second full moon is called blue moon. So since it has happened once in 2.5 years, people started taking for long period once in blue moon. So then I also started thinking, I was always looking for this blue moon, which I never saw, but later some of my friends corrected me that there is no blue moon, you don't have to be worried. This is only a... So there are things like harvest moons, because it is related to the harvest at certain regions. So because during the harvest period, they do it at night, then the moonlight is very useful for them, so they call it as harvest moon. It's like several names for the moons also. Now, just look at the internal structure of the moon. So you all know that the Earth structure you might have studied in your geography classes or going to study now. You have a solid inner core, and then a fluid outer core, and then you have the mantle, lower mantle and upper mantle. Then you have a continental crust. If you look at moon also have more or less similar internal structure. You can have comparison with Mars. So there are certain differences, but the internal structure, if you look at the moon and Earth, has a lot of similarities. So this leads to, now if you look at the origin and evolution of moon, how this moon is originated, how moon is formed, there are several theories. One is the fission hypothesis. That is, the rapidly rotating Earth could have thrown material out to form the moon. This was the first proposed one. But many of the things which we have seen sometimes back is not satisfying this theory. Then came the capture hypothesis. The Earth captured a celestial body in its orbit to become the moon. That also, because when you propose a hypothesis or theory, it should satisfy the observations. Otherwise, one or two satisfying will not work. Then there are some other theories like Co-Accretion Theory. The Earth and moon formed at the same time out of the same material, because by that time they got the idea of the structure, so then they talk about that. But then basically the angular momentum conservation and all was not satisfying many of those things. So today the most acceptable theory is the giant impact hypothesis. So far whatever we have observed about the moon is able to satisfy with this. So what it is actually, why this much theories came up? Because moon is less dense than the rocky planets. The moon is usually big for a satellite, which I mentioned in the beginning. So Earth-Moon system has lot of angular momentum, both spin and orbital motion. Then the chemical composition similar to the Earth's mantle. Then a tilted orbit relative to the Earth's path. All these observations finally concluded that the giant impact hypothesis, all these observations are, this hypothesis satisfied. What it suggests that a large body collided with the Earth, destroying the planet's mantle and sending so much of material into the space. And this got through in the gravity, came together and formed this moon. Probably this will help us to visualize that this impact, there are so much of particles, that body is called the Theia. This material started orbiting around the Earth, and the gravity on this debris pulled them together and eventually formed the moon. This giant impact hypothesis is actually the most acceptable one now. I'll go a little fast because you have to go home also. So We'll talk about the atmosphere of the moon. I have mentioned the moon atmosphere is very thin. It has only thousands of particles. But in Earth atmosphere, we have 10 raised to 19 particles per cc in centimeter cube. That thick atmosphere we have at the near surface. But if you go higher in the atmosphere, it gets reduced. If you go to Panmudi, it will be reduced. If you go to Himalaya, still it gets reduced. So that you know, as we go up in the atmosphere, the atmospheric density reduces. But this atmosphere on moon is produced from its surface due to variety of process. Even this thin atmosphere, how it gets formed due to micrometeorite impact, then heating by solar radiation, because large day-night variation, so a lot of weathering happens. Then the radioactivity of elements, so all these things contributed to this thin atmosphere. Because its gravity is so small, so whatever is there, it gets it means escape. So it is called, we have a thin atmosphere and a very huge exosphere. Exosphere is the region where the atmosphere is getting escaped from the planetary body. Our Earth also has an exospheric region at about 1,000 kilometers or so, where if you can see that there are escapes even from the Earth atmosphere. Even some of our molecules escape out of our thing, but it's not so large. So I was talking about the magnetic field. The Lunar Prospector mission on moon, it found out very small magnetic field regions in moon also. There is a discovery, that's why I'm just mentioned it here. Now, how to reach moon? There are experts here who might have talked or even going to talk further about that when they talk about the launch vehicle to you. But still, there are two ways you can reach moon. One is actually the fast way, the direct method, where it is the parking Earth orbit method, where it is directly going. The other one is the indirect method. But the direct method, the problem is we need to have higher velocity to be imparted to the spacecraft, which need high propellant and very powerful rockets. But it is quite fast, but it is quite expensive. Here it will be, first it will be reaching an Earth orbit, and then very high velocity will be imparted and reaches near to the lunar region, and the moon's, the sphere of influence, which will attract the spacecraft and get it into the revolve around the moon, which is quite fast method. But there is another method, is the indirect method, which Indian Space Research Organization is using. You have used this method for its Chandrayaan-1 and Chandrayaan-2 missions, where it has different phases are there, where actually this is the lesser velocity increase requirements will give, it's a cost-effective way. But what is more important is to reach moon, and very successfully ISRO could do that. What are these methods? One is actually an Earth-centric phase, then there is a lunar transfer phase, then there is a moon-centric phase. So in the Earth-centric phase, it is revolved around the moon, slowly it gets increased the velocity, and it takes some time, and finally reaches the moon's gravitational field, and then moon capture the spacecraft and it revolve around the moon. And there are several rockets, different types of rockets are there in the spacecraft, which will adjust its path and make it comfortable for an orbit around the moon. So now, so this way we can reach the moon. Okay, so you will listen more while going out also about these rockets and different types of rockets. So now coming back here to the missions to the moon, you look at this timeline. This was actually really fascinating timeline. If you look at this, you look at on October 4, 1957, USSR, you may not be very familiar, but it is United Union of Soviet Socialist Republic, the erstwhile, now it's called Russia and different countries around that. And you know that the fight between Ukraine and Russia, and they were all part of this USSR. So earlier, so this launched Sputnik, the first artificial satellite, in 1957. But 2 years later, in 1959, the Lunar 1 launched by the Soviet Union became the first flyby to the moon. The timeline is only 2 years' time. But of course, the preparation was quite long period was there. But the vision at that time was the moment they had a successful space mission, in 2 years they could make a flyby to the moon. So reached very near to the moon. So on 15 September of the same year, Lunar 2 by the Soviet Union crash landed on the moon. So some objects landed within 2 years in moon. which is about 4 lakhs kilometers from Earth. A month later, another Soviet probe, Lunar 3, sent back the first ever pictures of the far side of the moon. Near side you could see, but we don't know about the far side. But we could get the pictures. In 1959, the first successful flyby by United States. So there is a social science we might say about the Cold War period. So that time, there was a very popular president of United States, President Kennedy. He announced that USA would send a man to the moon by the end of this decade. That was a very big step because it's a great visionary. He could say that, and that the entire United States worked for that. Most of the all universities and institutes worked for that, and they made history. So in 1964, they had the Ranger 7 of the USA crash landed on the moon. Then 65, 66, different probes to the moon, and they started understanding the moon very well. And once they had a good understanding about the moon, there were several successful missions in 2 years time frame from 66 to 68. Rest of the things you get it in Google, so much of information, you don't have to worry about this. And what are the purpose of that? You can see here the nature of the missions. There are landers, there are orbiters. Lander landed on that, orbiter orbits around the moon. So in 2 years of time frame, both Russia and US had several missions so that they could have very good understanding about the moon, which helped them to design the Apollo program. So what is Apollo program? Apollo program is basically to fulfill the dreams of John F. Kennedy. By that time, Kennedy was no more. That was another story which you all know. So the Apollo program started, and there was in 1967, during the pre-flight test for one of the mission, which was planned for the moon mission, there was a big accident happened. So there was a fire accident, which the 3 US astronauts got killed in that. These are those 3 people, their names were given. So we should always remember those people who lost life for such a big cause. So we always talk about the success stories, but this also is a success story because failure is always required to have success. So when you have some failure, you don't have to worry, success is there ahead. So this is one best example for that. In 1968, Apollo 8 was the first manned spacecraft to go to the moon's orbit and back, followed by Apollo 10 in 1969, which was a dry run for Apollo 11 mission. And what happened was the Apollo 11. This is what Jenny Huston was mentioning in the beginning. On 16 July 1969, Apollo 11 took off from the Kennedy Space Center at Florida with astronauts Edwin, Aldrin, Armstrong, and Collins on board. On 20 July, the lunar module Eagles separated from the command module, and Michael Collins remained on Columbia, a big sacrifice. So when 3 people went to a place, 2 of them is going to touch, but he has to be on board. So that is a very big sacrifice. We should not forget his name, never, because of them only someone should be there to maneuver the spacecraft, then only other 2 persons can go and touch. So the Eagle landed successfully on the moon in the Sea of Tranquility. Neil Armstrong stepped out of the module and became the first man to land on the moon. And as she mentioned in the beginning, this is called, that's one small step for man, one giant leap for mankind. It's really great. It's for the science and technology. This was a great step. And followed, Aldrin stepped down to the moon around 20 minutes after and became the second man. And like all of us, when we go to any place, we also collect a lot of rock samples and we take a lot of photographs. The same thing both of them did. Rock samples were collected and photographs were taken during this 2 hours period, and then they came back. And we also got some of the rock samples in India at the Physical Research Laboratory. Later, several samples came, and we also contributed to this lunar program. Physical Research Laboratory, which is the mother institute for the Indian Space Research Organization at Ahmedabad. So there was a very good geochemist group. They worked on these Apollo samples, and even now some of the samples there, now, as part of Apollo 12, there were several funny incidents, and one of that in the Apollo 12 mission, the camera from the Surveyor 3, which was there in this list, if you look at, there this Surveyor 3 mission was somewhere here in 1967, which was a lander mission. So this lander mission left one camera there. So they picked this camera from the Surveyor 3. The Apollo 12 mission, astronauts picked it from there. This probe was brought back from Moon to Earth. So on analyzing the camera, it was found that there is a common bacterium, Streptococcus mitis. I don't know how to spell it correctly. So was alive on the camera. So naturally what we think in those days, at least those who found, there is life on Moon. It's indeed. So people started jumping, and immediately there were a lot of cry and this thing. But later they found that this bacteria which had got into the probe before the launch, because those bacteria cannot be there, those biologists, because when we physics students make mistakes in biology teacher will come and correct us. So there are efficient biology teachers at that time. They corrected them and told those which cannot be there and which got into the probe before the launch. And so then, but there it surveyed for 3 years. That's what another worry. So later, to avoid such confusion, nowadays, the subsequent probes are fully sterilized to avoid such a embarrassing situation. So such things also happened. There are many such things. So now in April 70, an oxygen tank exploded in Apollo 13. But they could come back. The moon landing was cancelled, and remarkably, all 3 astronauts returned back. So that is another interesting thing. And the third successful manned mission to the moon, Apollo 14, happened in January 1971. They did several scientific experiments, and the Alan Shepard famously hit 2 golf balls while on lunar this thing. So in Apollo 15 became the first mission to have lunar rover called Moon Buggy on this, and in the Apollo 16 holds the record of the fastest speed for wheeled vehicle on the moon, so they could move around. And Apollo 17 is the last manned moon mission, and Commander Eugene became the last man ever walk on the moon. So now, if you look at this, more than 70 spacecrafts have been sent to the moon. 6 manned missions landed on moon, and 12 astronauts have walked upon the surface till today and brought back 382 kilograms of lunar rock and soil to the Earth. And many of us, or my friends, were working on it. I am not working on it. I am not a geochemist, but I know some of my friends at PR are working on these things. So you can see at moon in the near side, most of this were on near side, and only one mission, which is actually the Chang'e 4, which is very recent mission, not Chang'e 4, I think. There is one Chang'e mission which is to the, this is the one, Chang'e 4, which is to the far side. But most of the missions were to the near side of the moon. And you know there is a near side and far side. So I'm talking about the lander mission. All these missions are all several lander missions. Now comes our mission Chandrayaan 1. So I should talk about that because the lab which I work, Space Physics Laboratory of Vikram Sarabhai Space Center, contributed significantly to this, the science of this mission. But this Chandrayaan 1, the Chandrayaan 1 is actually a remarkable achievement in lunar science. So when after a few years, people will be talking before Chandrayaan 1 and after Chandrayaan 1. The reason for that is Chandrayaan 1 discovered the evidence of water in the exosphere of the moon, as well as on the surface of the moon and also in the subsurface of the moon. So even Galileo, not even, he had only a small telescope. He also told there is no water on the moon. But here if you look at, so in the thin atmosphere of moon, the mass spectrometer experiment, which is from VSSC, Vikram Sarabhai Space Center, did this experiment, showed the evidence of water vapor and NASA's moon mineralogy mapper. This image is from the moon mineralogy mapper, an imaging spectrometer helped to confirm discovery of water logged in the minerals of the moon. You know the spectrometers? You know prism, when light passes through the prism with different colors. Okay. So you can have different colors which not only visible, you can have infrared, you can have far infrared. So there are spectrometers we can receive both reflected the radiance from the moon, and if you analyze that, you can get very important information So here this blue color shows the signature of water and hydroxyl molecules in the polar region of Moon. And the green shows the brightness of the surface as measured by the reflected IR from the sun with a wavelength of 2.4 micrometer, and red shows iron-bearing mineral called pyroxene. So this is basically from the Moon mineralogical mapper, but this is the one which we have sent. I think you can see this model here in this, you might have seen already. It looks very big here, but it's not to, I could have kept a pencil there to show its relative size. It's almost this size. Well, many of you might have seen it here. This gives the spectra, mass spectra, which shows the presence of water vapor. So you can see water vapor here. How will you identify water here? Because you have studied atomic mass unit in 8th standard, I doubt. Okay. So you know atomic mass unit is we use kilograms and grams for measuring mass, but when it comes to the atomic scale, we say AMU, atomic mass unit, which is 1/12 of the carbon 12 atom, 1/12 size of carbon 12 mass. If you divide by 1/12, you get 1 AMU. So here it is actually the mass in AMU in the x-axis. This is the intensity in the mass spectra. So you know atomic number? Yeah. So in atomic number, hydrogen, oxygen, all these have specific atomic number. Hydrogen atomic number is 1. Oxygen it is 16. Water is H2O. So it is 2 hydrogen atom and 1 oxygen atom. So the total mass, if you take 2 plus 16, so it's 18. So if you see in AMU, you can see at a hydrogen you can have a peak. At 16 you can have a peak for oxygen, and at 18 you have the water peaks. What it is actually this, we take all these molecules to this mass spectrometer, it enters through this, and there is an ionizing thing which gets ionized into different fragments, and it is subjected to an electric field. So this electric field guides these particles according to its atomic mass unit. Now you all are 8th standard students came here. So now you are a mixture. Suppose from your school, you have 8th standard, 9th standard, 10, 11, 12, all 5 standard classes, students mixed together and coming to the Space Museum, and we want to separate it out without talking to you. How can I do that? Your 100 students are coming. Some of them are you are in 8th standard, some of them in 9th, some of them in 10th. Okay, this 3 is enough. Now I want to separate 8, 9 and 10. 100 students are there. Without asking which standard, but I can ask you a question. I can interact with you in science. So how can I distinguish? So I ask a science question, which is for an 8th standard thing. Then what will happen? All of them will. Now a 9th standard one, if you ask, the 9 and above will think, 8 will left out, isn't it? The same, the 10th standard question if I ask, so you can separate it out through an interaction. The same way, if you have an electric field here and the particles are charged, there is a electron gun which will charge the particle. So when charged particle enters an electric field, there is a force acts on these particles. So the force acts on those particles depends on, one is actually the charge of the particle in that, and when the trajectory of the particle is guided by the mass of that particle, basically the atomic mass. So by adjusting the electric field, you can separate these particles according to its atomic mass unit. So you get separated into different atomic mass unit, and then you count. So when smaller atomic mass unit will come first, and then that will be counted. So for each electric field, there is a corresponding atomic mass unit. For each question, there is a student, 8th standard student. For another question, there is a group of 9th standard student and above. Like that, we can separate by applying different electric field in this instrument, so that we can count all the particles according to its atomic mass unit, and then we can find out what is the kind of composition. So depends on the resolution of this atomic mass unit, you can separate it well. So we could discover the water, our lab could discover water, presence of water. Another one which this VSSC discovered is the mini magnetosphere in moon. I told you that the Earth has a global magnetic field, but moon has magnetic patches, but whether they have a magnetosphere, but the experiments on board Chandrayaan-1 confirmed that there are localized magnetosphere called mini magnetosphere. This is actually the one. This Geophysical Research Letters is a very famous journal published by American Geophysical Union. So it will become a cover page. That discovery became a cover page for this great journal. The Chandrayaan-2 also equally contributed in a way. Chandrayaan-2 actually envisaged for an orbiter and a lander and had a rover also, but only orbiter is function. Lander had some issues which will be corrected soon. So one of the great discovery from Chandrayaan-2 is the global presence of argon. This is, argon is an element, noble gas. So the SPL came out, our lab came out with a global map of argon based on the instrument which observations using that thing. So this is actually, you can see the latitude and longitude, solar longitude, which is basically, it is a time dependent thing. Now, the Chandrayaan-2 also came up with several, very clear pictures. You can see that very high resolution pictures, that the picture resolution is of the order of 25 meters or so. So we could see the lunar terrain very well. And several such things are happening. The time is not sufficient to explain many things. So now we move. So why should we do this exploration? We have to spend a lot of money. We know that our resources are limited. We have to look for resources from outer region. One of the closest planetary body for us is moon. I don't know, we think that it never happens, but whatever we thought never happens is happened already. And so it's going to happen. Several things which we think is going to happen, isn't it? So these are going to happen now. So there are several resources which we look for from moon. One is the helium-3, which is going to be help us probably for the energy resources. Water and oxygen basically for those who want to have something in moon forever, you have to look for it. Then metal, silicons, rare earth metals, several things. So the use of lunar materials to facilitate continued exploration of the moon, we have to have an understanding. The use of lunar resources to facilitate scientific and economic activity of both Earth and Moon, we have to have an Earth-Moon system. Then lunar resources imported to the Earth can contribute to our life at Earth. So there are several areas where explorations are going to help. So what's for you in future? So you have to look Moon as a gateway for planetary and stellar studies. So now probably after maybe a few years from now, there will be a rocket launching station in Moon. You may go to there, and from there you will launch the rocket. We don't know, because you can be away from the Earth's gravity, which creates a lot of trouble, and it's probably from there it will be quite easy to do that. So you may work on Moon inhabitation. You have to think about what are the food which we can create in Moon. I don't know, from 10 to 20 years. I'm not talking about hundreds of years. I'm talking only 10 to 20 years. The last 10 years, science and technology happened. If you look at, in another 10 years, it's quite possible. So there is a program called Moon Village by European Space Agency. So they are envisaging something like this. So you might have heard about 3D printing, isn't it? If you can send robots and which can create 3D printing systems in Moon, probably they may print a village there. And we have to just go and live there. We don't know what is going to happen. So much, you just imagine it is going to happen. Yesterday's fiction is today's reality, so we don't know. So with this, I will stop. I took a lot of time.